Hello everyone. Today we are discussing about introduction of group theory. But before starting with the group, we will first define what is a binary operation. An operation which combines two elements of a set to give another set, give another element of the same set is called a binary operation. Let us take an example to describe what is a binary operation. Now, if we let any two elements of a given set of an integer, say 2 or 3, then we know that 2 plus 3 also is equals to 5, which also belongs to a set of integers. So hence the addition is an binary operation on z. Now take an example of ordinary multiplication. Now we will have considered the set which is containing the element plus 1, minus 1, iota and minus iota. And if we multiply any two member of set, say we have multiplied 1 and iota, then it will give us iota. If you multiply minus 1 and iota, it will give us minus iota. If you multiply iota and minus iota, it will give us 1. And similarly, we can see that during all these multiplications, the result which we got is belongs to the same set. So hence multiplication is an binary operation. We can say that in short, it means that if two elements combine from a same set to give another element of the same set, or the same, we can get same element, then hence the binary operation is satisfied. It means when two elements combine of the set to give the element of the same set. Now we will describe what is a group. A group non-empty subset G along with the binary operation a non-empty set G along with the binary operations star and circle is said to be a group if it satisfies the following postulates. Then a non-empty subset must satisfy a closure property. It means if A comma B belongs to G, say A is an element of an group and B is any other element, then the binary operation must also belongs to the group. Now associative property. The operation obeys associative law, or the group say we can say group must follow associative property. It means if A operation B and the whole operation C is equals to A operation B whole operation C, if they both are equal, then we can say that associative property is followed. Now the next postulate which has to be followed is existence of identity element. It means for every A belongs to G, we must have an element E belongs to G such that A dot E is equals to E dot A, which is equals to A. Here the element E is called the identity element. Now existence of inverse. If for every A belongs to G, we can find A inverse belongs to G, or we can say that an element B such that A dot A inverse or A dot B is equals to A inverse A, or B dot A, which is equals to A, where E is the identity of the given group. Then we can say that we can find the inverse of every element. Hence, if we are able to find the inverse of every element, then we can say that the inverse of every element exists. And if all the four properties are followed, then we can say that it is a group. Now, if a group also satisfy the commutative property along with the above four postulates, such that A dot B is equals to B dot A for all A comma B belongs to G, then we can say that the given group is an abelian group. Now we will define an example to show the given four properties. Now consider the given set G, which is equals to 1 comma minus 1 iota and minus iota as its element, and having binary operation multiplication. As we can say that every element when we multiply any two element of the given set, we will get the if we multiply any two element of the given set and got another element from the same set, then or a different element we can say, or we can say simply say, and if we multiply any two element and get an element from the set, then hence the closure property is satisfied. Here we can give an example: 1 dot minus 1 which is equals to minus 1 which belongs to G, 1 dot iota which gives iota which also belongs to G, and similarly so on. Hence the property of closure is satisfied. Now associative property. Now we all know that if we multiply any three element, or as in multiplication is always associative in nature, so hence we can simply say that it is associative, the given set is associative in nature. Now existence of identity. Here in the given set, we have 1 belongs to G such that if we multiply 1 with 1, we will get 1. If we multiply minus 1 with 1, we will get minus 1. If we multiply 1 with iota, we get iota. If we multiply minus iota with 1, we get minus iota. So we have an element such that 1 dot E is equals to E dot 1 dot iota A is equals to a dot 1 which is also equals to a, or we can say that here 1 is the identity element. Now existence of inverse. Here we can say that if we multiply 1 with 1, here we multiply 1 with 1 we get 1. If we multiply minus 1 with 1, minus 1 with minus 1 we get minus 1. If we multiply iota with minus iota we get 1. If we get multiply minus iota and iota, we also get 1. So hence we can say that for every element we can find an element such that if we multiply both of them, it will give us identity. So hence we can say that we have find the inverse of every element. So hence the given set is a group. Thank you everyone.